So here we are with exercises 5 and 6. You want to try to apply this rule to these three functions here. If you haven't done it yet, now is the time to pause it and do so. Okay, so now that you've tried exercise 5, let's check. This one, let's get the differences. Let's check if it's linear first. So if you do 28 minus 7, that is 21. If you do 112 minus 28, that is 86. And by 86, I mean 84. Anyways, it's not equal to 21. So if the differences are not the same, when the x differences are the same, then it's not linear. Maybe it's exponential. What if we do the ratio? 28 over 7 is 4. 112 over 28 is 4. What if we do 448 over 112, or 1792 over 448? Let's see, does that always come out to 4? Wait, 1792 divided by 448 is what I meant to say. Yeah, that's 4. So this is exponential growth. Now for part B, let's see. If we get the consecutive differences, let's start with that. 19 minus 10 is 9. 46 minus 19 is 27. Okay, so that's enough to know that the consecutive differences are not always equal. So it's not linear. Maybe it's exponential. What if we do 19 over 10 and 46 over 19 and 91 out divided by 46 and 154 91ths. That's going, let's work all those out here. Divided by 10 is 1.9. 46 19ths is 2.5789. That's enough to know it is not exponential. Let's just keep going with this. 154 divided by 91, something else. 91 over 46 is something else. So they're all different things. So those results did not come out to be equal, so it's not exponential. So this one is neither exponential nor linear. Okay, so for C here, let's see, if we want to find the consecutive differences. Well, first of all, the t-values are evenly spaced. That's going up by 5 each time. Is the same thing happening here if we subtract these? 65 minus 50 is 15. 80 minus 65 is 15. 95 minus 80 is 15. 110 minus 95 is also 15. So, yes, this is linear. And if you know it's linear, you don't need to check. It's not exponential. Okay, so For exercise 6, if you want to find a formula for each of these functions, this is a challenge. It's good to do if you're trying to get an A, or if you just want to try something difficult. This is a difficult thing to do. So this one is exponential. It's going to be of the form f of x equals a times b to the x. And I know the a is going to be 7. So, because that's what it starts with. So the question is, what is the b? So we know that if you plug in x equals 2, the result should be 28. And I want to figure out the b, so I'm going to try to get rid of the 7. Just divide both sides by 7. That's going to give you 4 equals b squared. Okay. That should tell you that b could be 2. So does that work? Can we say that f of x is 7 times 2 squared? Oh wait, not times 2 squared, 2 to the power x is what I meant to say there. That should work. If you want to check that, it's a good idea to plug in some other numbers, which you can do with a calculator. So if I want to plug in 4 into this function I just wrote here, that's going to be 7 times 2 to the power 4. Oh yeah, that gives you 112. If we do 7 times 2 to the power 6, does that give you 448? Yes, it does. So it looks like this is the right formula. I'm going to skip to C, because C is a little bit easier, because we know it's linear. So if it's linear and you want to get a formula for it, we just need to find the slope. The slope is this change in y divided by the change in x, or h of t and t in this case. And the change in y between each ones that we got is 15, and the change in x is 5 between each pair of points. So 15 divided by 5 is a slope of 3. And we know the starting value, the y-intercept, is 50. So once we know that the slope is 3, you can write this as h of t equals 50 plus 3t. Okay, so that's that one. This one is not exponential. It's not linear. Maybe it's a power function? I don't know, actually. I did write this question, but I don't remember what the answer was, so I'm going to be figuring it out here too. So maybe it's g of x equals something like k times x to the p. That would be a power function. Actually, it can't be a power function, because if it was, when you plug in 0, we would be getting k times 0 to the p, which cannot be equal to 10, because this is going to be 0, and 0 is not 10. So it's not a power function. Let's see, maybe it's a quadratic function? Like maybe it's g of x equals ax squared plus bx plus c. And I'm not going to go through the work of figuring this out here. I guess I kind of noticed that if you take the 10 away, if you look at a table with just x and g of x minus 10, what I noticed is you'll get 0, 9, 36, 81, and 144. And I recognize those numbers as the squares of x. So I noticed that g of x minus 10 is equal to x squared. So the formula for g of x, you could add 10 to this and get g of x is equal to 10 plus x squared. So if you got that one, congratulations. That was an extra tricky problem that I haven't really shown you how to do before. But you should be able to get, hopefully, exercise 6 with C. Getting a linear function should be something you know how to do. A is a little bit trickier than that, but if you got that, good work. And then C is extra tricky. Anyways, that is that section. That was a long one. Good work sticking through it. Hopefully you learned a lot from this, and hopefully you can get started on the 6.2 homework as soon as possible so that you don't get behind on that. All right. Have a good day. And again, I should have said 6.2 is also going to help you prepare for 6.3, the way that usually goes. So that's a really good reason to do the 6.2 today. Take care.